नहीं, ये उधर चल ही रहा है, लिंक कट गया तुम्हारा। नेचर ऑफ साइंस।
Sorry to be technical error. Sorry to be technical error. Now we start again. Nature of science. Nature of science 6 describe the nature of the scientific enterprise and the characteristics of the knowledge it generates. What is the nature of science? It helps us better define the boundaries of science and non-science. It increases student interest in developing awareness of the impacts of science in society, the better understanding of science, and what types of questions science can answer, how science differs from other disciplines, the strengths and limitations of scientific knowledge, key tenets of NOS, nature of science. Tentative niche. All scientific knowledge is subject to change in light of new evidence and a new ways of thinking. That does not mean that we shouldn't have confidence in the scientific knowledge. Rather than rather that it may change in the future. Observation and inference. Observation involves gathering information using the five senses, while inferences are explanations based on observation and prior knowledge. Empirical evidence. Scientific knowledge is derived from data and evidence gathered by observation or experimentation. Scientific laws and theories. A law is a succinct description of relationship or patterns in nature based on observation and is often expressed mathematically. Scientific theories are broadly based concepts that make sense of a large body of observation and experimentations. Objectivity and subjectivity. Scientists strive to be objective and employ self-correcting mechanisms such as peer review, but intuition, personal beliefs, and social values, scientific methods. Scientists employ a wide variety of approaches to generate scientific knowledge. There is no single universe method. Creativity, a source of innovation and inspiration in science. Scientists use creativity and imagination throughout their investigations. Processes of science. Processes of science. It is through the process of science that knowledge is gained. Scientists collect information by using processes skills, that is, observing, classifying, measuring, relationship, predicting, formulating hypotheses. Science the process. Examples of scientific processes. Problem solving and applying, controlling variables, operationally defining, observing and recording, using equations and math, interpreting data. Processes, classifying, experimenting, modeling, measuring, communicating, predicting, etc. These are all the examples of scientific processes. Science as attitudes context. Science includes a set of attitudes that encourage people to engage in scientific study. Attitudes, open mindedness, willingness, collaborate, and learn. Scientific attitudes. Scientific attitudes, curiosity to explore their environment and question what they find. Keenness to identify and answer questions through carrying out investigations. Creativity in suggesting novel and relevant ways to solve problems. Open mindedness to accept all knowledge and tentative and to change their view if the evidence is convincing. Perseverance in pursuing a problem until a satisfying solution is found. Concern for living things and awareness of the responsibility they have for the quality of the environment. What is not included in science? First, science does not make ethical or moral judgments. And second, there is no good or bad, right or wrong in science. And third, value judgments are made by paper. Responsibilities. Responsibilities. It's the responsibility of mankind to understand how information is obtained through the scientific processes and to make informed ethical decisions on the use of that information. The three facts of science are interrelated. First is content, context, inquiry. The three facets of science. Sorry, facet. No. The three facts of sciences are interrelated. Inquiry begins with an understanding of current content knowledge. Inquiry produces new content understanding. Context sets the goals and rationale for inquiry. Content knowledge is used in new technologies that affect the societal context. Content knowledge influences policy making. These are the three facts of science. Okay, I'm watching again. The attitude of questioning and reasoning, its approach of believing only facts supported by relevant evidences, where these evidences are derived from observations, logical interpretations, and conclusions made from experiment or experiences which are repeatable under similar conditions. Believing things to the extent of evidence availability, science temper is a true pathfinder and guide for our life. It's not only complex scientific methodology, but it's built on a solid base of humanity, freedom, courage, fearlessness, and humanity. This thought process, which believes believers runs mixed on by natural knowledge. Critical thinking. It is the ability to analyze our experiences and review our actions through reflecting on them. It requires an abstract thinking to reflect on our actions. We use critical thinking to evaluate whether something is adequate, correct, useful, or desirable. You can nurture critical thinking among your learners by encouraging them to review their work for further improvement. So discuss with them about the failures or mistakes in previous work. Also, discuss the alternate ways of addressing a given problem. If one doesn't seem working, it is better you ask open-minded questions using working. It is better if you ask open-ended questions to encourage your learners to analyze the information and really think on the various aspects of a given problem or experiences. Logical. It requires thinking with logical reasoning. Logical thinking is the essence of having scientific temper as it makes you focus on your observation and organize them carefully through reasoning before arriving at any conclusion. You should keep we shall discuss each of the steps in some detail of the reshape scientific method. Observation. Scientific method demands that the observation be carried out in a systematic manner, taking due care to ensure that it is free from any bias and experimental errors. Often the observation involve measurements, and there are always some uncertainties associated with this arising from the instruments used for measurement. like weaning balance, thermometer, titration equipment, etc. This can be quantified and need to be clearly stated to avoid spurious conclusions. Uncertainties may also rise from the presence of uncontrollable factors influencing the phenomena under investigation, and due care has to be taken to eliminate this. This is especially true in a study involving living organisms, be it plants, animal, or human being. The nature of these instruments are, of course, different in social sciences and could take the form of interview, notes, case studies, questionnaires, etc. And so the degree of precision is comparatively lesser. Hypothesis. The formulation of an hypothesis to relate the various variables observed influence the phenomena is mostly a creative act, an act of intuitive insight and thus not easily amenable to description. The most important characteristic of a scientific hypothesis is that it should be variable rather falsifiable. Thus, the hypothesis that magnetic substances contain young angles who get attracted towards ferries containing magnets. But these angles and ferries cannot be seen by humans. Is not testable since the angles and ferries are so designed that we can never see them. It is therefore not a scientific hypothesis. On the other hand, the hypothesis there are no young angles in magnetic substances. It is testable. One can falsify or can be catching on such angle. Similarly, the hypothesis that light bends strong gravitational fields verifiable and even suggested measurements that can be made to test classify the claim. Prediction. The power and utility of a hypothesis lies in its ability to make predictions about phenomena other than the one which forms its basis. For example, Newton's hypothesis regarding existence of gravitational force between objects could be used to make such diverse predictions as the phases of the moon, phase of Venus, and the hour of maximum tide in the stream. All these predictions were verifiable. Similarly, Einstein's formulation of the hypothesis of relativity prediction that clocks inside a vast moving spaceship would slow down as compared to an identical clock on Earth. It took almost 50 years before this could be experimentally verified and give credence to this hypothesis. The other starting outcome of the theory was equivalence of mass and inertia. We also verified much later in a particle physics. The predictions from a hypothesis may be made using logic or where the hypothesis is mathematically formulated by using mathematical tools, as was the case with gravitational and relativity verifications. The most crucial aspect of the scientific method is verification of the prediction of the hypothesis by performing suitably controlled experiments. The need for control over the experiment is of paramount importance since otherwise random chances factors can force us to draw wrong conclusions. Many of the so-called superstitions in the various societies are associated with some spurious cause-effect association noticed in some winter observations. Thus, a cat crossing the road or someone sneezing before you live, your own being had omens. The number 13 being inauspicious, etc., are said to be superstition since these hypotheses have not been stabilized repeatedly in control experiments. The difference between a superstition and a scientific theory essentially lies in the repeated verifiability of the latter in a pre-planned control experiment. Thus, while testing the efficacy of a drug, the doctors need to ensure that the effect observed are indeed due to the drug and not due to some random chance factors. This is usually done by taking two groups of patients. One group is given the drug under test, and the other is given a placebo. That is a like pill of some common substance like milk or sugar. Without the patient knowing about it, statistical techniques are often employed to ensure that observed difference between two groups is significant to a high degree of a probability that the conclusions are not distorted by experimenters' guesses. You must also be cognizant of the fact that the process of verification is always tentative and within a certain domain of experimentation. There is no way that we can prove any hypothesis for formal proofs are possible only in mathematics. In fact, we cannot even truly verify our hypothesis. We only fail to refute it. The history of science is replete with examples where some hypotheses elevated to the status of laws of nature. After repeated verification, were seen to be limited applicability in the light of new finding or wider domains of data. The most notable example is that of Newton's law of mechanics, which we now know are valid only when the velocities involved are less than the speed of light. Since the domain of human experiences involves velocity very much lesser than the speed of light, the laws of mechanics got repeatedly verified before Einstein brought in his relativistics formulation. Yet that verification did not lend finality to these laws, much less prove them. And we know now that these laws do not give an accurate description of the principles governing the universe. Thus, we need to bear in mind the tentativeness of all scientific theories. It is, in fact, not proper to call these as laws of nature, since as pointed out by Dempere, the world law imparted a kind of moral obligation which bade the phenomenon with the law led to developing scientific temper overview. In this new unit, we shall understand the essence of scientific method, the characteristics of scientific temper, and the method by which you can develop scientific temper among the students and teachers in schools. We shall also understand how scientific method can be extended to all aspects of everyday life, including spiritual pursuits. Objectives. After studying the model, you should be able to explain the essential features of the scientific method, define the characteristics of scientific temper, identify the strategies for developing scientific temper among students at various levels of school education, apply the scientific method of all aspects of everyday life, including spiritual pursuits. Inquis- Inquisitiveness is a fundamental trait of human beings. From times immemorial, man has tried to comprehend the world in which he finds himself. The knowledge gained through observation of natural occurrences like apparent movement of sun, moon, and other heavenly bodies, storms and lightning, eclipse and meteorized growth and properties of plants, etc., was gradually systemized and classified, and the process of identifying causal relationship was initiated. The roots of modern science and scientific method can be traced to the early attempts to relate cause and effect. On full moon nights, the waves in the sea were always higher than on moonless nights. Eating certain plants always inducted intoxication stones thrown at a certain angles of inclination traversed the largest horizontal distances, etc. Another crucial step was identification of parents in observation. Full moon nights and moonless nights occurred at regular periods. There was noticeable periodicity and a pattern in occurrence of weathers. Rains always followed summer, winter followed rains, and spring followed winter. Many plants followed in spring and withered away in summer. Certain diseases proliferated only in summer and others during monsoons, etc. Repeated observation of such patterns and causal relationships led to induction of generalization of theories, many of which were often raised to the status of laws of science. Once the deductions from these theories were experimentally verified repeatedly, this, in essence, is the process by which even modern scientists progressively understand the nature better, thus enabling us to harness its potentials for the welfare of humanity. The scientific method. Thus, the scientific method can be seen as comprising of five steps. First, intensive observation of the phenomena and a study with a view to identify the various parameters influencing it and any causal relationship between these. Second, formulation of a general hypothesis to explain the phenomena. This hypothesis could be some kind of causal mechanism or even a mathematical relationship between the variables influencing the phenomenon. Using the hypothesis to make predictions about the existence of some other phenomena or about relationship between variables derived from mathematical and logic. Verifying. Verifying these predictions by performing carefully controlled experiments. If the experiments validate the predictions, the hypothesis is accepted as a theory or even a law of nature. But if the experimental results are at variance with the predictions, the hypothesis is either rejected or modified. Here's a figure. Prediction. The power and utility of a hypothesis lies in its ability to make predictions about phenomena other than the one which forms its basis. For example, Newton's hypothesis regarding existence of gravitational force of attraction between objects could be used to make such diverse predictions as the phases of the moon, the phases of Venus, and the hour of maximal tide in the sea. All these predictions were verifiable. Similarly, Einstein's formulation of the hypothesis or relativity predicted that a cloud inside a fast moving spaceship would slow down as compared to an identical cloud on Earth. It took almost 50 years before this could be experimentally verified and give creditness to this hypothesis. Observation. Scientific method demands that the observations be carried out in a systematic manner, taking due care to ensure that it is free from any bias and experimental errors. Often the observation involve measurements like mass or temperature or an object, agriculture, yield, blood chemistry, etc. And there are always some uncertainties associated with this arising from the instruments used for measurement like mean balance, meter, titration equipment, etc. This can be these instruments are of course different to social sciences and could take the form of interviews, notes, case studies, questionnaires, etc., and show the degree of precision or comparatively leisure prediction. Power and utility of a hypothesis lies in its ability to make predictions about phenomena other than the one whose from its basis. For example, Newton's hypothesis regarding existence of relationship or subtraction between objects could be used to make such diverse predictions as the phases of the moon, the phase of Venus, and the hour ex-mitre tidal in the sea. All these predictions were verifiable. Similarly, Einstein's formulation of the hypothesis of relativity predicted that a cloud inside a fast-moving spaceship would slow down as compared to an identical cloud on Earth. It took almost 50 years before this could be experimentally verified and give evidence of this hypothesis. Thank you for thank you for now it's time to end up this session. Thanks everyone for your support and cooperation. Hope we have learned from this meeting. Once again, thanks to our respected participants and school. Thank you.